Hello class, in today's video we're going to be looking at parallel and perpendicular lines. The learning intention of this video is we're going to understand what it means for a line to be classified as parallel and perpendicular. We're going to be able to determine whether two lines are considered to be parallel or perpendicular using their gradients. And lastly, we're going to be able to find the equation of a parallel as well as a perpendicular line given a point along the actual line itself. The first thing that I want to show you is about the different relationships between two different lines, okay? So lines can run in different directions. You could either have a line that's classified as a parallel, and as you can see by these parallel lines, these lines over here, they don't actually intersect, meaning they don't ever touch or meet each other at all, and they have the exact same distance apart from one another. Other relationships between lines is you could either have an overlapping line, an intersecting line, and a perpendicular line. Okay, now if we were to exclude the parallel lines, the overlapping lines, the intersecting lines, as well as the perpendicular lines, they all have something in common and they all have something referred to as a point of intersection. So that's just a position found along the actual line itself. So it's a coordinate where these two lines actually meet or cross. Now, obviously, for a parallel line, as you can see here, you don't actually have a point of intersection. So I've abbreviated this word over here to POI. So you don't see any point of intersection for parallel lines. Now, for a intersecting line, as you can see, there's only one point of intersection. Now, for an overlapping line, there's actually an infinite amount of point of intersections, as it goes here, pretty much all the way because it's overlapping one another. And for a perpendicular line, we also see that there is one point of intersection. However, this particular relationship over here is very special because these occur at right angles. Okay, so this is a special type of an intersecting line. Now, because this lesson is mainly focused on about parallel lines and perpendicular lines, I'm going to show you guys two methods that we can use to determine whether these two lines are parallel, perpendicular, or neither. When I'm saying neither, I'm talking about lines that may intersect with one another, but they don't actually occur at right angles at all. So one of the methods is by looking at it through graphically. So if you have two graphs over here, you can kind of eyeball and roughly gauge to see whether these lines are considered to be parallel, perpendicular. But this is probably not the most reliable method, okay? So, and what I mean by that is because like it's a bit hard for you to gauge whether this is going to be exactly 90 degrees. How do I know that it might not be 89 degrees or even 87 degrees, okay? So this is probably not the most reliable method. And the second method is doing it algebraically, okay? So what I mean by this is you're going to be comparing two equations and you might be solving for a few things. So that's what I mean by algebraically. And this is the method that I prefer you to use. Even if it's done graphically, you will still need to use some algebra in order to deduce whether these lines are considered to be parallel, perpendicular, or neither. So the very first one we're going to be looking at is parallel lines. Now, before we actually get or show you the relationship between these parallel lines, I want you to quickly comment and compare these two parallel lines. What features do you guys see that are quite similar between these two parallel lines, and what features do you see that are different? So what I mean by that is I want you to talk about stuff like about the gradients, comment on the x-intercept, as well as comment on the y-intercept. So do that and then we'll go through the answers together. Now, all of you guys should have been able to identify that the similarities between these two parallel lines is that they have the exact same gradient, to mean they have the exact same rise over run. And as you can see for these two lines over here, they both have a negative gradient because they move in this particular direction, okay? So if we had the equation for both of them, what I'm saying is that the m value, your gradient value, is going to be identical when you've got two parallel lines. Now, the differences, as you can see over here, you can clearly see that they have different y-intercepts as well as different x-intercepts. So your c values for parallel lines are not the same, but your m values for the two lines will be equal to one another. So we already said that parallel lines are lines that never meet, so they never intersect and have the same distance apart. In order for you to work out whether two equations or two graphs are parallel, we need to compare the gradient, so the rise over run, to see whether they're the same. So that's how you can work out whether something's parallel. And we already discussed that x and y intercepts will be different, okay? So in this case over here, I'm showing you that the gradient is going to be the same, so the rise over run. So in this case over here, remember that I said that gradient is gradient is pretty much a measure of how many units do you go up for every unit you go to the right. So in this case, if I move 1 unit to the right for both of these, I'm going down or up by the exact same amount. So in this case of here, your rise over run is going to be -1 because you're going down 1 for every 1 unit to the right. So therefore, in this case, your gradient for both of these lines is going to equal to -1. And if you wanted the actual equation for it, then it's going to be these equations over here. And notice that, again, I don't ever write a -1 in front of x because it's just implied in this case over here. And then notice, again, that your y-intercepts for both of these will be different when you do have two parallel lines that are not overlapping with one another. So in this case, if I've just got for more examples over here, just to show you that the gradient for any two parallel lines will always be identical. We're now going to be looking at the relationship between perpendicular lines, okay? So in order for you to help you understand, we're going to explore the relationship between the perpendicular lines by finding out the gradient for each of these lines shown below. So what I want you to do is, using the coordinates that's been outlined, I want you to please find out the gradient of the blue line. So therefore use these two coordinates. And when you're trying to find out the gradient for the red line, then you're going to be using this coordinate as well as this coordinate, since these coordinates are found on this particular red line. So give yourself 3 minutes, and then I'm going to show you guys the relationship between the gradients for our perpendicular lines. Now, if you've calculated this correctly over here, this is going to be some light revisions. So I'm going to represent this as x1, y1, x2, y2. If I substitute this into my formula, then what I'll get is a gradient that's equal to 2/3. Okay, and if I did the exact same thing to calculate the gradient for the blue line, then what you would have noticed is that your gradient is going to equal to -3 on 2. Now, if you please carefully look at these two values over here, notice that there is a relationship between these two gradients over here. And in this case over here, the relationship is that these two numbers are the negative reciprocal of one another. So what I mean by that is, if you kind of flip the fraction and add the negative sign in front of it, then that's the relationship between these two values. So we refer to that as the negative reciprocal. So as I said on my slide here, the gradients of any two perpendicular lines are the negative reciprocals of each other. Just to give you an example of what I mean by negative reciprocal, say that this is the gradient for one of them, so that's 7/4. The gradient for the other line that's perpendicular to it will be -4 on 7. So what they've done is they flipped your numerator as well as your denominator and then added a negative sign. For this example down below, -5 on 9, if I was to flip that fraction and add another negative, two negatives make a positive, so therefore my answer would be 9 on 5. And therefore I've got more examples over here just to show you guys the relationship between the gradients for two perpendicular lines. Something that I do want to point out is that it's a bit easier when your gradient is already in a fraction, but in this case over here, because this is your gradient is a whole number, I recommend that you express this as a fraction. So it'll be 2 and 1, and therefore once it's in this particular format, then you can clearly flip the fraction and then add a negative sign, which is why this gradient is equal to -1/2. Now class, please have a go of answering this question over here. Give yourself 1 minute and then we'll compare our answers together. So for this question over here, what I'll do first is I'm just going to state what is the gradient that's present in the equation that's given. So for this equation over here, your gradient is going to be equal to -2 and 1. I've intentionally rewrote -2 as a fraction, as this will just make it a bit easier for you guys to see the flipping process. So if I was to find the gradient of the line that's perpendicular, I've used this symbol over here. That just means the perpendicular. So the gradient of a perpendicular line is therefore equal to +1/2, because two negatives make a positive. For this one over here, the gradient is currently 7/8. So therefore, if I flip it and add the negative sign, it's going to be -8 on 7. This particular slide over here is just a summary of what we've already gone through. So if you want to copy down these notes over here, go ahead. But some of you guys might have some further questions, okay? So you might be wondering right now is, if two lines have the different gradients, what would that actually look like, okay? Meaning that they're not, which means that the gradient is not identical and that the gradients are not the negative reciprocal of one another. And as I said earlier on, it's just going to be two lines that are going to be intersecting, but they won't be intersecting at right angles though. And if you do happen to have an equation that does have the exact same gradient as well as the exact same y-intercept, that particular graph of there, if you sketch both of them, then you're going to produce two lines that are going to be overlapping with one another, and therefore you will have pretty much an infinite number of solutions or points of intersections, okay? But you don't really need to know that too much, but for you will need to know this particularly for year 11 and year 12 maths methods. Now I'm going to show you one more example over here so that you can actually see whether two lines are considered to be parallel, perpendicular, or neither. And I'm intentionally going to be using a different or a more complex example that's a little bit different, okay? And the reason why this example over here is a bit different is because I've got both of these equations that's expressed in the standard form, so it's not expressed in the slope-intercept form, which is the y equals mx plus c, okay? So the way that we're going to determine whether the gradients, whether the lines are parallel or perpendicular or neither is by pretty much comparing the gradients. So if that's the case, what I'll need to do for both of these equations is I'm going to have to transpose or rearrange the equation into the slope-intercept form, into the y is equal to mx plus c form. So in this case of here, if I'm going to do that, I'm going to have to get y by itself. So I'm going to subtract 3x on both sides, okay? So therefore, if I do that, then this will cancel out this. So therefore, my equation would therefore be 2y is equal to negative 5 minus 3x. I'm trying to isolate y. So now I'm going to kick off the coefficient by dividing all terms found on each side of the equation by 2. So if I do that, I'm now going to cancel out these two over here. Therefore, my equation is now going to be y is equal to negative 3x on 2 minus 5 on 2, okay? And all I've done is I've pretty much shifted this to the front instead, because we often like to have the term with x at the front of the equation, okay? I'll do the exact same thing for the second equation. So I'm going to subtract both sides by x. This will cancel each other out. So therefore, I'm left with negative y is equal to 2 minus x. Notice that you've got a negative y in front, so I'll divide both sides by negative 1 to get rid of the negative sign. And if by doing so, my new equation is now going to be y is equal to x minus 2. Now, once you've rearranged the equations for both of them so that they're in the y is equal to mx plus c form, we're now going to be comparing the gradients, okay? So remember, we said that when the gradients are the same, they're going to be classified as parallel. When you've got a perpendicular line, you're going to have the gradient that's going to be the negative reciprocal of one another. And when it's neither, that's when the gradient is neither the negative reciprocal and it's not the same as well. In this case over here, the gradient is negative 3 and 2. This one is positive 1. You'd notice that they're not the same. Neither are they the negative reciprocal of one another. So therefore, the answer is going to be neither in this case. What I want you to do right now is I want you to refer to my examples to now answer this question. So determine whether these two particular equations over here are considered to be parallel, perpendicular, or neither, okay? So give yourself 3 minutes and then we'll go through the answers together. If you guys have done this successfully, you'll notice that this equation over here is already rearranged. So I'm going to leave that guy alone, but I will need to rearrange the equation on the right-hand side. So what I'll do is I'm going to add x to both sides of the equation. This will therefore get rid of the x found on the left-hand side of the equation. I'm therefore left with this, and now I'm going to divide both sides by 2. Therefore, my equation is going to be is equal to x over 2 plus 5 on 2. And now what I'll do after that is I'm going to now compare the gradients of both of these equations. This over here is positive half. This one over here is also positive half, okay? So the gradients are the exact same for both equations. Therefore, the lines over here are therefore going to produce two parallel lines. So that's the answer for this particular question. We're now moving to the final stage of this lesson, which is about finding the equation for a parallel line as well as a perpendicular line, okay? And it's going to be quite simple because you already know how do you find the equation of any straight line. And we just looked at the gradient for any parallel line is going to be the same, and the gradient for any perpendicular line is going to be the negative reciprocal. So I'm going to show you one example, and then I'll get you to do one question on your own. So for this example over here, you're trying to find the equation that's parallel to this bad boy, and it's saying that your parallel line passes through this coordinate. It's not saying that this equation passes through this coordinate. It's the one that's parallel to it passes through that coordinate, okay? So we know that the equation of any straight line can be represented in this form, and we know that because it's parallel, it will have the exact same gradient. So we already know the gradient for your particular equation. So your equation for your parallel line is going to be y is equal to negative 3x plus c. We don't know what the y-intercept, what the value of c is. So in order to find out the value of c, we're going to substitute this coordinate because we know that this coordinate is found along that particular line. So if we sub that coordinate in, so this is where your x value goes, this is where your y value goes, this is what your equation would now look like. What is negative 3 times 1? Well, that's going to be negative 3. Rearrange the equation to solve for c. So I'm going to add both sides by 3 to cancel out this. And if you did that, then you're going to get an answer of 8 because 5 plus 3 is equal to 8. Now your equation is equal to y is equal to negative 3x plus 8. So as you can see over here, this is actually quite easy if you guys already know how to find the equation of a straight line. So what I want to get you to do now is I want to get you guys to do this on your own. But in this example over here, it's going to be perpendicular, okay? So I'm just going to note that there for you guys. So please give yourself 3 minutes and then we'll compare our answer together. If you guys have done this successfully, okay, the gradient for the one that's perpendicular is going to be the negative reciprocal of 2 and 3. So flip the fraction sign and then add the negative. So it should be negative 3 and 2. Or you could even leave it as negative 1.5. Doesn't matter at all. So in this case over here, we know that this is going to be our equation. So let's find the value of c. So we're going to substitute the coordinates 2 and negative 1. Therefore, this is what your equation will look like. Now, in this case over here, I'm going to multiply these two because that's the multiplication. So negative 3 times 2 is negative 6. Negative 6 divided by 2 is going to equal to negative 3. So now I'm going to solve for c by adding 3 to both sides of the equation. So if I did this, this will cancel each other out. So therefore, c is going to equal to negative 1 plus 3, which is equal to positive 2. I made a mistake of there. And therefore, your final answer is going to be this with a positive 2 as well. Alright guys, in terms of the textbook questions, these are the questions that I'd like you to do. Initially on the actual check list, I think I did include question 4, but I've eliminated that, so don't worry about doing question 4. And I've made a small adjustment. I initially told you to do all questions, but I'm only going to get you now to do just the first column for question 2. And I think that if you guys actually answer questions 1, 2, and 3, this should be more than sufficient enough to prepare you for your actual post-test. But I recommend, if you can, please do the other questions. I think I'd be happy if even if you did 5, 6, and 7, and you don't really have to do question 8 at all. So that's pretty much the end of today's video, guys. If you've already finished that, then there's also a Google form available, and I'm hoping that you guys are able to address the 2 success criteria of this lesson. Thank you for watching. I'll see you guys again in the next video. Bye.